Hi everyone, and thanks for watching. I'm Kirsch Mackey, an electrical and electronics engineer at Altium. In some of the previous videos, we've been talking about power distribution in your PCB, how power gets delivered to regulators, and how to think about power distribution in a PCB. One of the questions that often comes up when placing power connections in a PCB is, how should you route these power connections? What should you do if a board has more than one voltage level? Should you use power rails or should you split up a power plane? In this video, I'll show how you can route your power connections both ways in Altium Designer. We'll look at both methods so it's easy to see how to use the program to implement both styles of power routing. Let's look at how to do some of these tasks in Altium Designer. If you want to follow along with this demo, there's a link in the description where you can download a free trial version. To get started, let's take a look at the high-level power delivery topology we typically want in a board with multiple voltage levels. Typically, you have a DC input, and this needs to be regulated down to lower voltages to deliver power to groups of components. So here we'll have first regulator, and we'll call this reg 1, second regulator, reg 2, and the third regulator, reg 3. The input section at the top of the diagram is often routed using a power plane to ensure high current carrying capacity across the PCB. This is also something that's required in high-speed PCB design. The output lines could be routed as traces or you might want to use an additional power plane if each section carries high current. If you're operating at low current, it's fine to use traces or small polygons on the surface layer. However, it might be difficult to provide power to every component on the board. You might need to provide power to different circuits at different voltage levels. Or you have dense groups of components, or you might be operating at very high currents in some areas. In these cases, it's usually best to have a power plane, and you can cut the plane up into sections. To provide different voltages as needed. Let's look at how to do some of these tasks in Altium Designer. If you want to follow along with this demo, there's a link in the description where you can download a free trial version. Right, so we have a printed circuit board here, and in this design I will add some voltage rails, and that's just traces that provide the voltage I need. So what you do is you do your routing, Now, normally I don't like going under components, but in this situation, there's a lot of space under there, so that's okay for me. And the voltage rails are convenient because I can just route my traces directly to where my nets are, and I don't have to worry about doing a lot of extra work. I like just routing the nets for my voltage rails because I don't have to do a lot of extra work. They're very direct. And this helps me plan out my initial design as well. It's very easy, simple, straight to the point. Now this is useful if I am not that concerned about the amount of current that needs to be sent to or delivered to my component areas. I can size my trace width and just make my connections and move on. Likewise for this VMON here, I will just make this connection and do this. All right, so voltage rails are quick and easy to use for when you're working on a design, and you can just move on. It's very fast. However, take a look over here. Here we have copper polygon pour, and this lets me pour over multiple component devices without having to individually connect all of my traces. This is very useful because I can definitely supply enough current for the application, for my devices and what they need. This is another method as well. But oftentimes, if I know I'm going to a multi-layer printed circuit board, minimum 4-layer PCB, I like to use split power planes. So what would be the difference between using voltage rails and traces and copper pour on top versus a split power plane? Well, when you have a split power plane, you have a dedicated layer of copper that has an extremely low impedance. Notice here, these traces, they have a higher impedance, and therefore there's some limitations. If you can get lower impedance voltage supply rails or voltage nets, then you want to do that. Also, having an power plane directly adjacent to some ground plane helps with capacitive coupling and providing free capacitance that would help source currents. To various devices, therefore reducing the chance of voltage rail collapse or ground bounce, which is also a sort of voltage rail collapse, but on the ground plane. So let's go ahead and make some split planes. Now, what are split planes? Split planes allow you to break up the areas of copper. This is a full plane, all solid copper on this third layer, this power layer. And those areas cover and provide voltage to all manner of components around it. So I would probably have an area for VIN all around here under my VIN devices, my VIN nets. And here's VIN, that's easy to take a look at. And also for VMON1, I would place a split plane area that's sectioned around here. And finally, my 3v3 digital, I think I'll split up my plane to cover these devices as well. So let's go ahead and create a split plane. You'll get low impedance, higher current carrying capacity, increased capacitive coupling between ground plane and the power plane, and more options for routing. So with my third layer active, I would just go ahead and single out my VIN area, use a regular line, and then split up my plane like this. And here I'll section off my 3v3 digital power. It has a copper pore on top of it, which is fine. I'll still add a split plane anyway underneath it. And here I'll make sure this connection is met. All right. Now this is a regular line, not a trace or track. It's just a regular line to help me split up the plane. There we go. Now that's not the end of it. It doesn't know that these specific areas or regions are supposed to be for VMON and 3v3 digital or VN. So what I'll do is double click on each area. So let's go ahead and double click on each area, and I'll set this to VMON. Set this to 3v3 digital and set this area to VN. Now I can make connections from my VN traces, or better yet, my VN pads, anything connected to VN. I can delete these traces that have a higher impedance than the plane anyway and create fanouts instead. To create fanouts, I need vias that go from layer 1 to 3, and let's plan this ahead. So let's go to the design layer stack manager. Here I can set my via types, and I have a blind via identified to take me from the top layer to the third power plane layer. So going back to my PCB, I'm going to add some vias. For vias, I will set them as VN. And change it to blind. So let's go ahead and place this. Notice the immediate connection to the third layer for VN.
And I like to place a via for every power or ground connection that I want to take to my power or ground plane. Having a via for each pin that wants to go to my VN split power plane allows me to have a very low impedance for each of my power connections. I'll also go ahead and place more vias, but this time it will be in the VMON region. So the same via I can take from layer 1 to 3, that's for VN. I can take the same type of via, place it, and set it to VMON, and it will connect. Now my VMON pins now my VMON Now, like over here, my VMON pins can get a path to ground. Now, like over here, my VMON pins can get a path to their voltage plane. Now my VMON pins can get a path to the voltage plane using this via. And here I can even delete some of these traces. And here I can even delete some of these traces. Avoiding potential voltage loops. This method gives me a lot of freedom in how I want to place my vias and how I can route my PCB because I have multiple power planes on one area. Free from needing to accommodate a bunch of traces or routing. It has very low impedance and source a lot of current or sink a lot of current and provides some capacitive coupling between itself and also the ground plane, which helps with preventing voltage rail collapse.
Thanks for watching this feature video. Hopefully this shows you what to expect when using PCB design software like Altium Designer. If you're interested in learning more about Altium Designer, you'll find a link in the description where you can check out the software and download a free trial. Please like this video so others can get a chance to see it as well. Also, please subscribe to the channel if you want to stay up to date on every new video we post. And finally, if you'd like to learn even more than what you watched in this video, please click on the link. Thanks for watching.